Hello, everyone, and welcome to our December 2023 Waste Management Sub-Community of Practice Eco Session. My name is Francis Ochen from the African Society for Laboratory Medicine, and I am your host today. Our session, as usual, will run for 1 hour. We will take one presentation and get into the discussions. Your only way to join us is through the chat, and please send in your questions, comments, or responses to comments that are running in the chat through the chat platform. We do have real-time language interpretation, and we ask you to be on either the English, French, or the Portuguese channel, so that when we're doing counter interpretation, you're not at a loss. These session materials will be shared with you through our multiple online platforms, including our WhatsApp page, the online library, and some of this will be done immediately after the session, and then those that require processing, we'll do those in a day or two. Today, we are getting back to waste management, a truly fundamental piece in every service and product industry, but most importantly in the healthcare sector, given the nature and immediate plus the long-term effects of the waste that we generate in healthcare, and of course their effects on us as part of the environment. And so having a comprehensive waste management system that is sustainable and comprehensive in the fact that we should have competent policies, guidelines, and procedures, competent staff that are implementing the procedures and policies, and of course, choice of appropriate technologies, their deployment, maintenance, and ongoing monitoring are really, really fundamental. And it is not just desirable, but we think that it is obligatory for every institution to be doing this. And so in today's session, we provide an overview of the holistic approach to a successful, sufficient, and sustainable waste management system, with a focus on autoclaving, biodigestion, and recycling. And to take us through this, we have a very important presenter today. Janita Hoffman is our presenter today, and Janita is a medical sales representative with Mediclave based in South Africa. So allow me hand it over to Janita at this point, and then we'll rejoin at the question and answer sessions. Janita, over to you.
Perfect. Good afternoon, ladies and gentlemen, doctors, professors, and honorary members. This afternoon's session will be a holistic approach to ensure a successful, sustainable waste management system. A quick webinar overview: what is sterilization, ways of achieving sterility, safe disposal of medical waste and the process thereof, and safe disposal of live tissue and how it works, in other words, pathogens. And then just a small closing word. So I'm going to jump straight into it. What is the difference between these two devices? Visually, the answer will be there is no difference. But in fact, there is a difference. The one is sterile. The point that I'm trying to make is sterility cannot be identified with the naked human eye, therefore making it very difficult to separate sterilized items and non-sterilized items. Let's go into a little bit more detail. What is sterilization? The definition of sterilization is the elimination of all transmissible agents from surfaces and or equipment. Sterilization is a probability as it cannot yet be proven, and it is measured with the sterility assurance levels as a 1 to 6 log reduction. As alternatively, as I like to refer to it, is the battle against the bug. There are many ways of forming sterility, like hydrogen peroxide, ethylene oxide, formaldehyde steam sterilization, and normal steam sterilization. This will be the one that we are focusing on today, as autoclaves are associated with steam sterilization. they use steam as a sterilant for the equipment inside. So steam sterilization benefits are they are non-toxic to patients, staff, and environment. Their cycles are easily controlled and monitored. They have rapid cycle times, and they penetrate deeply into medical packs as well as your device fluids. So how does an autoclave operate? As you will see on your left, steam enters into the chamber at a set pressure, which in return will determine the temperature required. So pressure and temperature walks hand in hand. This temperature will be maintained for the required time for a specific cycle due to the pressure required and the volume needed in the chamber. So a normal cycle or a standard cycle will consist of preconditioning, heating up, sterilizing or your exposure time, exhaust, drying, vacuum break, and your door release, which will enable the autoclave to open its doors. The typical autoclaved items are your hospital instruments and equipment, pharmaceutical products, laboratory media, veterinarian surgical instruments, soil for certain plant production, milk bottles, and the most important that we'll be focusing on today will be medical waste. So most of the figures that I used regarding medical waste was extracted from the WHO second edition article, Safe Management for Waste for Healthcare Activities. So what is medical waste? The term medical waste includes all waste generated within healthcare facilities, research centers, and laboratories related to the medical products. In addition, it includes the same type of waste originated from minor and scattered sources, including waste products in the course of healthcare undertaken at home, like home dialysis or self-administration of insulin. If you look at the pie chart, the dark gray section is what we'll specifically be focusing on today and what needs to be sterilized prior disposal or recycling. There are many different categories of medical waste, so we'll briefly look at them. However, I will only be focusing on medical waste and the pathological waste. So you get your hazardous waste and non-hazardous waste. Hazardous waste is sharp waste like blades, infusion sets, or needles. Infectious waste, waste contaminated with blood or other body fluids. Pathological waste is your human tissue or unused blood products. Pharmaceutical waste is waste containing cytotoxics, drugs, and chemical waste would be your blood pressure gauges and batteries. Radioactive waste is any radioactive therapy treatment. In your non-hazardous waste is the general healthcare waste, which is waste that does not contain chemicals, radioactivity, or physical hazards. One of the most common problems amongst countries is the management of hospital waste and the negligence or improper handling thereof, often generating threats to healthcare workers, communities, and the environment. A prime example of this is the article attached below, Gauteng Health Investigates Illegal Disposal of Medical Waste. About 2 weeks ago, in the busiest city of South Africa, Johannesburg, there was illegal medical waste dump in an open air field. So let's look at the chain of infection. Chain of infection starts with infection agents, a microorganism that can cause disease. Then you get your reservoir, a place where the microorganism can thrive and reproduce, typically in a human body or in animals. Portal of exit, a means for a microorganism to leave the reservoir, so through your respiratory, skin, mucous membranes. Mode of transmission, how the microorganism moves from one place to another place. This will be physical contact, droplets, or even if it's airborne. Portal of entry. Portal of entry is an opening allowing the microorganism to invade a new host. And suspectable host is a person susceptible to the disease, lacking immunity or physical resistance to prevent the infection. And then obviously it starts from the beginning. So it's a chain reaction, and if it's started, it never ends. Ideally, medical waste should be processed in a certain way. Firstly, the medical waste disposal process is collecting the medical waste separated out by type, making it easier to reuse, reduce, and recycle. Hospitals, pharmacies, and other healthcare facilities use different colored bins and bags for the collection of certain types of medical waste. For example, red bags are used for biohazardous waste, while special marked sharp containers are used for needles and other objects that can possibly puncture the skin. Next, the separated waste is collected and transported to the disposal facility. At the facility, it is placed in the autoclave, which uses steam as a sterilization method, making it an environmental friendly process. Medical waste needs to be autoclaved in order to successfully, sufficiently, and sustainably kill the virus, bacteria, and other microorganisms, which is what makes medical waste dangerous. Once the process is completed, the waste can now be reused, reduced, or recycled, or in normal cases, simply disposed, since the hazardous pathogens have been killed. Although this is the ideal process, certain or even most countries are still not completing all of the steps. This makes it difficult to recycle, reuse, and reduce, in certain cases, still having a large environmental impact. In some countries, they have made recycled medical waste and are now manufacturing plastic containers, flip-flops, and even bricks with the recycled waste. So imagine what we can do if we all recycle medical waste. A minimum approach to the overall management of medical waste. All operators dealing with medical waste should be familiar with the main categories of medical waste. As previously mentioned, the hazardous waste or non-hazardous waste. So they need to familiarize themselves with those categories. As set out in either national or local regulations on waste classification. As a minimum, managers responsible for medical waste should conduct a walkthrough of the facility to identify the medical areas that produce waste, to obtain initial emission of the types and quantities of the waste, and to understand how the waste is handled and disposed of. A rapid assessment should provide sufficient data to identify problems and begin the process of addressing the problems. In 2014, Mediclave was approached by a former chief technical expert from the United Nations Development Programme, Jorge Emanuel, to aid in developing a robust, sustainable, and environmental friendly autoclave for safely treating infectious waste. This collaboration resulted in the development of a highly successful, sufficient, and sustainable waste autoclave, manufactured in Africa for Africa, because we understand Africa's needs. The development led to projects that were rapidly completed under the difficult Ebola crisis, where we installed 20 units in the countries like Liberia, Guinea, and Sierra Leone. Thereafter, the project led to further installations in Ghana, Madagascar, Tanzania, and Zambia that were funded by the Global Environmental Facility. Please enjoy the video of our waste units being installed during the Ebola crisis as it was a crucial time and we are privileged to have had all our staff return home safely.
We've been having problem with our waste, especially in terms of the infectious waste that we have here, because all of the waste that have been generated here are infectious waste, and it's very difficult for
Apologies about that. It seems like the network's not working, so the video doesn't want to work. We'll maybe try and revert back to it in the end of the session. So I'm just going to continue. The key objectives in considering any technology or protocols should be as follows. The hazardous factor to healthcare workers, communities, and environmental impact, sustainability, simplicity, reliability, viability, and effectiveness of the equipment, initial capital layout, long-term cost effectiveness, easy equipment operation, backup service and on-site technical support, energy efficiency, water usage, and chamber load capacity or process capacity. However, it remains the institution's responsibility to ensure successful, sufficient, and sustainable waste management systems. In order for the facility to form the successful setup, the following needs to be taken into consideration. Implementation and maintaining of institutionalized healthcare waste management procedures and practices in the facility. Implementation and sustaining maintenance schedules. Forming of support groups and or even forums. Proper training and skill transfer of or to administrators, healthcare workers and nursing staff, waste workers and cleaners, operators and maintenance technicians. A few technical specifications of the autoclave that we were part of developing with the UNDP project is the effectiveness, easy to use, robust, affordable, and appropriate for the conditions in Africa. It has multiple vacuums with sterilization at 134 degrees Celsius or 121 degrees Celsius. It's manufactured by Mediclave, which is located in South Africa, Pretoria. It's developed in collaboration with the GEF and the UNDP project. The waste units that were installed during the Ebola crisis were the 260 litre chambers that were about 1 hour to an hour and a half cycle per cycle time. They are certified to meet or exceed international autoclave standards, and they include an on-steam boiler with all stainless steel construction. It also has an easy sliding door, low maintenance and reliable, and it has a special trolley with a barrel to collect waste. The whole barrel slides into the autoclave to be sterilized after treatment. The barrel rotates to dump out the treated waste. With our efforts to save water and power, we have developed a construction program, or a constant program, to continue improving our water and power consumption. With this program, we have managed to lower our water usage to date by 70% and our power consumption by up to 50% compared to a traditional autoclave. Water-saving technology is introduced to reduce water consumption, and each autoclave records the water usage per cycle, along with all the cycle parameters for recording purposes. Due to the waste loading space within a round chamber, the processing capacity of a square chamber versus a round chamber is drastically more, increasing the load and energy efficiency and decreasing overall unit footprint. The main advantages of this technology to remember is the effective, easy use, robust, affordable, and appropriate for the conditions in Africa. Low maintenance and reliable in comparison to other technologies, manufactured in Africa for Africa, and it is an eco-friendly way of waste treatment. This will be a typical layout or loading of a waste unit. So you'll start with placing your waste inside the stainless steel barrel at the top here, closing the lid, and once it is full, you'll move it to the autoclave. You'll close your sliding door, and once the door is closed, you'll start heating multiple vacuums and sterilization cycles. After about an hour and a half, when the cycle is finished, you'll open your door, remove the sterilized barrel, and you can unlock your rotator barrel to dump the treated waste at the bottom. Once that is completed, your trolley and barrel is ready for some more waste collection. With the autoclaves, we managed to change the Ebola crisis from this to this. So here you can see a lot of emissions still emissioning into the air. Here you can see soil contamination. And over here, if you look closely, there's a bird that's actually transmitting the contaminated items. This is also a hospital in Tanzania that's successfully, sustainably treating their waste. So this is before the cycle, and this is once the autoclave has sterilized and compacted the sterilized items. And on the edge here, you can see these items are now ready for recycling. So typically this will be used for making the flip-flops or the containers or even the bricks. I would also like to use this opportunity to briefly introduce you to our latest technology, the tissue dissolver, which is also locally manufactured in South Africa. As you will see on the left, this is the most compact unit, which can easily digest up to 5 kg of soft tissue or pathological waste. The EnviroJet tissue dissolver uses potassium hydroxide or KOH, alkaline hydrolysis, at an elevated temperature and atmospheric pressure to convert proteins, nucleic acids, lipids of all styles, tissues, and infectious microorganisms to a sterile aqueous solution of small peptides, amino acids, sugars, and soaps. Once dissolved, it has safely converted animal and human as well as microbial tissues into a sterilized EPA neutral aqueous solution suitable for disposal into a sanitary sewer. The EnviroJet process sterilizes and digests in one operation, reducing the volume and weight by up to 97% and completely destroying pathogens. The process is environmentally responsible, releasing no dangerous emissions into the atmosphere. The complete dissolving process time is approximately 16 to 24 hours. This is dependent on the tissue weight, size, and the load. Here you will see an example of chicken being processed. The chicken was just being processed for demonstrative purposes. So we started with an empty chamber. We filled it up with 5 kg of chicken, and then we drizzled over our alkali sachet with the KOH. And after 16 to 24 hours, this was the result. Only a few bones and teeth left. However, in this case, there were no teeth left because they were only chickens. All biological indicators used in efficiency testing of the EnviroJet tissue dissolver have been destroyed. These tests were the Geobacillus styrothermophilus spore strip in a gasoline envelope at a concentration of excess of 10 to the power of 6. All infectious waste will be sterilized in the EnviroJet due to the temperature and the time exposure. So previously, I mentioned the vital parts of sterilization is time, temperature, and pressure. And again, in the EnviroJet, it's time, temperature, and pressure. The waste on the following list will be completely sterilized and digested, leaving only remnants of bones and teeth. After treatment, animal carcasses, human cadavers, sterile tissue, fixed tissue, infected tissue, and frozen or fresh tissue. Although the EnviroJet is specifically designed to both sterilize and dissolve tissue or other degradable waste, if you have infectious waste that you wish to sterilize in the EnviroJet that is not on the above mentioned list, please contact Mediclave for guidance. There is a rapid depolymerization of ribonucleic acid, RNA, and slower destruction of deoxyribonucleic acid. This is most important in the implication for potential infectious material. Both RNA and DNA viruses are completely inactivated by the heat element of the process. So once again, we're moving back to the vital steps, which is temperature, time, and exposure. The alkali itself is consumed by generating the salts of the hydrolysis products. The only byproduct of the tissue digester are mineral constituents of the bones and teeth or vertebrates. They are soft enough for after the organic matter has been degraded to easily be crushed even by your bare hands, and therefore you can use it as calcium phosphate powder or sterile bone meal. The EnviroJet tissue dissolver, the sachets are conveniently pre-packed with KOH or potassium, minimizing the handling risk factor associated. So the first sachets will be packed, the ratio between the two will be 120 grams of KOA alkaline for each kg of tissue mass. Then 120 grams will be for 2 kg, so it will work up. Otherwise, you can use a larger sachet of 600 grams for every 5 kg. So obviously, if you use the 600, you'll have to use 2 600-gram sachets for 10 kg tissue mass. Closing word will be manufactured in Africa for Africa because we understand Africa's needs. Our core business is manufacturing, refurbishing, servicing, maintenance of all types of steam autoclaves across Africa. And I leave you with these striking words: excellence presents the wise choice of many alternatives. Thank you, ladies and gentlemen, doctors, professors, and honorary members for granting us the opportunity. I trust that you found the webinar informing, and I trust that you'll use the knowledge gained well.
Thank you. Thank you very much, Janita and team, for taking us through comprehensively, reviewing a little bit of the general waste management principles, and then focusing more on autoclaving, which is really our areas of focus today, and then biodigestion, which I see is very, very applicable in most of our histopathology labs, and how to then get rid of the remnant tissues that are no longer going to be used for purposes of diagnosis or monitoring treatment. We have a number of questions that have come through the chat. I will encourage colleagues to continue sending in your questions through the chat, and we'll deal with them. So as we get to the question, I think I'll start with one general one from Simon Ojore, and Simon is asking. He wants you to relate proper waste management with the scaringly escalating levels of AMR, antimicrobial resistance, that we are seeing. Do you see any relationship between proper waste management or improper waste management and AMR? And Janita, if you want your other colleagues to step in, you can call on them to try and support with this. But we could start with that first question.
Okay, Francis, I just want to confirm the question was the relation between the waste, improper management, and proper management.
So he wants us to try and share with him the relationship between proper waste management and antimicrobial resistance, if there is any link between the two anyway. And I was just adding that it could be proper waste management or improper waste management. Does it have any relationship with antimicrobial resistance?
So proper waste management is the ideal situation that I listed in the presentation. The way that it's making it proper waste management is the first segregated, then afterwards going to the facility. If it's not segregated, at the facility, you get maybe limps, or sometimes you get your needles, your waste units, all of that is going into one autoclave, making it very difficult to reuse those items or recycle those items. So it's just difficult if you don't follow the correct steps to recycle the equipment.
Thank you. Thank you. And Simon, if you have any relationship that you're aware of, you can as well put it in the chat. The other way of looking at it is that waste management is meant to get rid of both microbes, but also we dispose of other pharmaceutical wastes through proper waste management, not necessarily autoclaving. And so if you have pharmaceutical wastes that include drugs that are disposed of inappropriately, and you have animals that might be getting exposed to suboptimal doses of those drugs that are in the environment. And of course, they may be having the microbes that cross between humans and animals. Even if it remains in the animals, then you can almost be sure that there will be some level of resistance that you will be breeding because of your poor pharmaceutical waste disposal. That's one way of looking at it. And there are, of course, multiple ways that you can think about. I know that there is a colleague whose hand is up. I'm not sure Fitsam has the right to allow him comment. Is that the colleague from Mediclave? Geoffrey, are you from Mediclave? Just put a thumbs up in the chat if you are, and then we'll give you a chance to comment.
Sorry,
yes,
sorry,
Janita.
Francis, he's not from Mediclave, no.
Okay, so we'll take his comment in the chat, and when time allows, we probably will allow him to say it out. The second comment or question from Simon Ojore is on One Health approach, and he's just asking, how can One Health approach help with proper waste management? Janita?
So is he asking from a hospital point of view, or is it just from overall health approach?
The general One Health approach. And I can actually also relate this to another comment that came in, but I think the general benefit that we can get, Simon, from this is the fact that if you have the human health team working with the animal health team and of course the environmental health team, you can pull your resources together. Some of the waste management plants are actually very costly, but of course, that's their worth. But to allow for pulling together resources through the One Health approach, you can actually have 1 or 2 plants that are put up, and then it is even optimally utilized, because then you can have wastes coming from the animal health sector, the human health sector, and the environmental health sector being destroyed or managed within those facilities. If you had only one sector with one huge plant for waste management, probably it wouldn't be cost effective, because even you might be utilizing it to only about 20%. So that is one way I would look at it. But Janita, if you have a comment on the One Health approach, how can it really support with proper waste management? You could just throw a comment out there.
So currently in South Africa, we have medical waste as well as other waste. All of our medical waste is being transported to one facility where it is sterilized and disposed of. It does make sense to have one central plant for multiple places or facilities to revert back to. So I do agree with you, Francis. It is costly if you have to have a waste unit on each facility, whereas if the facilities can maybe draw together and have one unit or a larger unit, and then they can sterilize their waste at one facility, making it a bit more cost effective.
Thank you, Janita. Our next question is coming in from Matsebula, and Matsebula is asking, do you as Mediclave have other low maintenance technologies for chemical recycling? And it pulls out xylene and formalin. So do you have other products other than the biodigestion units plus the autoclaves? Do you have other products that can support with chemical waste management besides this that you've spoken through?
Unfortunately, not yet, Francis. The only 2 that we have is waste management and then the EnviroGest. We do have normal hospital autoclaves, but unfortunately nothing for the chemicals yet.
Okay. Thank you. Thank you very much, Janita. I'm running through just to make sure we have all the questions addressed. I know that we have a colleague who is also supporting with responding to questions in the chat. So this one comes from me, and I'm taking us back to the sterility assurance levels. And I know that you've really highlighted how we should then be certain of the degree of degradation, or how much of the microbes are gotten rid of from every item or surfaces that we're dealing with. Kindly comment on, is this a claim from the manufacturer that can be verified at the receiving lab? If I received your autoclave and I want to do a verification for sterility assurance level, is it possible that I can do it, or it will always need the intervention of the manufacturers?
Francis, you are able to use any sterility assurance product. However, if it comes to when you're purchasing a product, you can contact Mediclave and we can assist you with that.
Okay. Okay. Thank you. Thank you very much, Janita. Geoffrey, I am trying to look up your comments in the chat. Did you put it in the chat? Your hand is still up. Fitsam, you may want to give Geoffrey the rights to say something, just very briefly. Geoffrey.
No, I actually wanted to know the definition of affordable in Africa. Can we talk about the cost? So how much? So if I'm running a hospital, or let's say I'm directing or I'm in charge of a particular hospital, what's the cost of these machines that you have? And then let's talk about the maintenance as well. Like, how does it go about? Is there going to be any agreement when I buy the machine and your organization? I just want to know about that.
Thank you. Thank you very much, Geoffrey. And for our record, you're the first to ask a question on the platform. We try to limit it as much. Thank you very much. Question orally, not questions in the in the chat. So Janita and Tim, do you want to take up that question?
Thank you, Geoffrey, for your question. So I can answer you on the service level agreement. We do service level agreements. So the services will be 2 minor services a year, as well as 1 major service. So there's 3 services a year. And then the cost of the autoclave, if I can maybe ask you to send me an email, then I can send you a breakdown for the cost of the autoclave. We do also provide on-site maintenance training. So basic training for the operation of the autoclave, as well as basic maintenance training to maybe replace, say, an element or gasket and so forth.
Thank you. Thank you very much, Janita. And on the question of relativity with cost, and I know that you raised that as well, Geoffrey, what is affordable and probably what is not affordable. So that generally is relative, but it depends on what probably the product is capable of doing, the running cost versus the longevity that you expect from the product. And so that discussion can be taken at that level with those considerations before you can come up with a position. And again, like we have indicated here, pooling resources would be really one way of trying to make sure that in one location you can have the set of units that are important for you to handle your waste in the right way. Remember, it is not a choice. We don't have a choice, but we have to deal with the wastes that are generated, and we had better plan for them from the start, not leaving it as by the way that we then deal with as we've already started doing most of the work that we tend to do. I also would like to thank Ed. Ed has indicated here, I know that I noted this at the start of the session, that we'll have multiple side seminars next week at the ASLM conference, and one of them will be on waste management. And so we'll have additional discussions on waste management, and we should all be interested and join that discussion for those that will be able to make it to Cape Town. And I've also noted that there is no reason not to get there. You should be getting to Cape Town to have both the waste management side seminar, the other side seminars, plus the main conference delivered to you in real time. I have a question on, I know that you gave us guidance on what products and what wastes can be handled using both the biodigestion method plus also the autoclaving. Do you want to pull out some of the wastes that you don't seem to think can be handled through autoclaving and biodigestion? Of course, biodigestion will have to deal with tissues. But autoclaving, are there those that you pull out and you can easily say, this we cannot handle through autoclaving, and therefore as you plan for setting up your waste management system, you can break it up into those that can handle this, and therefore you still would require other options that can support you with handling other wastes that cannot be handled through autoclaving. Janita, over to you.
So the waste units are currently, they can sterilize any medical equipment. However, it's just subject to manufacturer. So I won't advise for endoscopes to go into autoclave. I know that the autoclave steam is quite aggressive. So putting that into an autoclave does sometimes damage endoscopes. However, things that can't go into an autoclave is human body parts. So that's where the tissue digesters step in. So you can't put in, say, like an amputation into the waste unit. It's just going to come out a mess. So that's why the tissue digester is there. And then it's also vice versa. The tissue digester can't do the waste in the tissue digester. The waste is for the waste autoclave, and then tissue digester is only for lymphs. So your blood, your tissue, your pathological waste. So any pathological waste can go into the tissue digester. And although it sterilizes and dissolves, it can't do your waste.
Thank you very much. Thank you very much, Janita. And I would also like to recognize again another comment from Ed on the link between poor waste management and AMR. Besides what we have already discussed, it brings up some very interesting perspective here. The fact that microorganisms that are coming from hospitals, others may be partially exposed to antibiotics, and they may already be developing some resistant genes to a certain group of antibiotics. And if these microorganisms are not dealt with properly and you get them out there in the environment, chances are that they will get to other animals, or they will transmit the genes for resistance to other microorganisms that eventually might end up with humans or other animals. And therefore, pulling that case of AMR if really waste management is not handled the way it should be handled. I have another comment coming in from a colleague. I'm just trying to look it up. We are running low on time as well. But I just want to pull one or two more comments or questions for us to deal with. In the meantime, I know that colleagues are very interested in the cost. Janita, do you have some indication of the costs? Given the volumes, I know that there are different sizes of your units. And so from the autoclave side, given the sizes, maybe 5 liters, 50-liter capacity, do you have some indications of cost? But the other question that I would also want you to deal with besides that is I see that the units, the autoclaving units actually do sterilization and compacting. And yet we have medical devices and lab apparatuses that are supposed to be recycled. So if you have glassware that you need to sterilize and then reuse, how does that play out with the compacting component of your units? Is it feasible that they can be used, or are there functions that allow for compacting, and at some point you can actually run cycles without compacting?
Thank you for the question, Francis. So we have a normal standard autoclave that's used in medical hospitals, and then we have our medical waste units. So the medical waste units are for medical waste, and that's where it comes in, the compacting comes in. It's not exactly a compactor, so it doesn't compact like a physical weight. However, the melting and so forth of the heated element does compact the items. Then the hospital autoclave is the one where you can sterilize your glass items in. So you get a set cycle for your glass, and then you can sterilize your glass items as normal as you would in a hospital for your instruments or so forth.
Okay, and then the cost indications for the different sizes of both the autoclave and the biodigesters.
Okay, Francis, we've got a few sizes of the medical waste units. So we've got a 260 liter, a 1,300 liter, and a 7,000 liter. And then the biodigester, we're not ready for pricing yet, as it's still in verification stage. So we still need some qualifications and so forth on that. But I can give you prices so long on the medical waste units. So the 7,000 litre will go for about 2.3 million rand. I'm not sure the conversion will have to be worked out per country. And then I'm just going to ask my colleague if he can help me with the 1,300 and the 260 litre.
Okay, is the colleague coming in now?
Sorry, he just advised me it's for the 260 litre, it's 450,000. Also in rand, so you'll work out your rate per country, and then the 1,300 litre will be 700,000 rand, give or take plus minus.
Okay, so colleagues, you have to get your currency converter so that you can get to know how much it might cost in dollars or in your local currency. Thank you again very much, Janita. We have a question from Ali Dumbia. I think this came in French, and I was struggling to do my translation of that. He's asking, he's just saying he would like to know what ways you propose for organic wastes, including liquid, because this seems to be one of their major problems. So the liquid waste, organic liquid waste, but also glasswares. What are some of your comments on their being able to be autoclaved or rendered safe through autoclaving?
Francis, we can do a liquid cycle on your normal medical waste unit. So then it's just an extra cycle on your normal medical waste system. That's why it's also advisable to have one unit in an area with different facilities to also bring their items. So, I mean, a liquid cycle will only be used for a certain type, however, medical waste will be used for a different one. So not all of the cycles will be used at one facility. That's why it's recommended to have multiple facilities using one waste unit.
Thank you very much. And some of these details are provided during installation, even prior to acquisition. I would encourage that for those who may be interested, prior to acquisition, you share all your circumstances with whoever is going to be able to provide you with the piece of equipment that you need, so that then your need is built into the selection of what you finally get, but also the accompanying training that goes with it. Colleagues, we have barely 5 minutes to end up this. I must thank everyone for joining. If you could drop your screen, Janita, and be preparing to give us your final closing remarks. You're not yet starting now, but I wanted just my colleague Fitsam to put up the polls plus also the certificate codes. Unfortunately, we are unable to take up questions, live questions. We will only be taking up those in the chat. And I think we have barely enough time to take one more, given the amount of time that we have. And thank you, Ed and colleagues who have been really helping with comments in the chat to make sure that this very important topic is comprehensively handled. We know that we cannot complete it entirely here, and that's why we are encouraging us to join the discussions in Cape Town, physically or virtually, but also continue to follow up everything else that we will be bringing up with regard to both waste management and other topical issues that we deem very important for our community of lab practice on the continent and beyond. At this point, allow me ask Janita to come and just give us your closing remarks.
I just want to thank you once again for the opportunity. I just want to mention we do support throughout South Africa and the rest of Africa. But if you have further questions or queries, please do not hesitate to contact me via email. I'll also put my email in the comment box. And thank you very much for the opportunity. Thank you, Francis.
Thank you. Thank you very much, Janita. So for colleagues, and I generally think most of us do, who may need proof of attendance, please get to the code on the screen and be able to access your certificates. Should you have any difficulty, please reach out to us so that then you are provided guidance on how to access your certificates. If we can then just have the polls up, and then I will put the last slides talking about the ASLM conference next week briefly. Just to also note that the recording for this session will be shared both on the WhatsApp platform for those who are there, on our online library, and all other media outlets that we use. Some will be immediately after the session, then others will come your way in a day or two because we have to process them before we post them on those platforms that we use.
Thank you, Francis. Yeah, the poll seems failed to launch.
It's fine, thank you. It's fine, no trouble. Let's just, you can take down your screen. And then I just share one last screen here. So just letting us know, like colleagues have been indicating, even if you haven't registered, please, you still have a chance to attend the conference next week in Cape Town. You are allowed to come and register on site. We also have multiple side sessions besides the main session. And so you will select, I am lost for choice. You will select which ones you can attend and which ones you might defer for just getting the recordings. We have all those happening next week in Cape Town. And so until we meet you there or we meet in the next session, we are also not very certain if we have another session before Christmas. And so I will take this opportunity on behalf of ASLM to wish you the best of your holidays break and a happy 2024 up until when we then meet with our next session. From us to you, have the best of your afternoon, evening, or morning, given the location you're joining us from. Thank you.